Let me okay. I think it's started. Let me rename this part 2. Okay, hi guys. Happy Easter, first of all. In this video, what we're gonna do, or this stream actually, so I think yesterday we stopped with systems of equations, like 2 linear equations. The one thing that I did forget to do was linear inequalities, so we're gonna go ahead and do that. So we're gonna go ahead and review. Let me put this up a little bit. We're gonna go ahead and look at linear inequalities, okay? Now, linear inequalities. Let me actually get another marker, because... let's see here. So obviously, you know, linear inequalities, so when we learned about, I'm just gonna go ahead and explain how an inequality works really quick. So when we say, for example, and this is where we introduce, like, or actually, I'm gonna introduce interval notation so that y'all know what I'm talking about. That's what I'm gonna start with. Okay, interval notation. So, there's a rule that says, I'm trying to think. So number 1, A is less than or equal to X is less than or equal to B. In interval notation, this is what we call an interval, right? And interval notation would be, it would be, so let me kind of just, an interval notation that would be bracket A to B, okay? That's how you would do it. That's how it is in interval notation. It's like bracket A and then comma B bracket. There's another one that says if we have, and let me actually zoom it in as much as I can because I know that. Okay, so there's another one that says A is less than X is less than or equal to B. When it's a less than, you do parentheses A, comma B, and then bracket, right? That's how you would do it. When we have A is less than or equal to X is less than B, it would be A, like it would be bracket, and then A, comma, B parentheses, okay? That's how you would do it. And the number line, by the way, I'm gonna just go ahead and do the number line really quick. So the number line would, and let me just kind of do a little, okay, so the number line, let's say this is A, this one is B. So you would go ahead and basically it would look something like this. From A to B, right? You would color in from A to B with closed points like dots. And for this one, it would be A. And I mean, of course, I can always do like endpoints. So basically that's A. I can do it something like this, and then I can do this, right? And then I can say that this closed dot here is B, being that, you know, that's kind of, and it goes on forever, right? From A to B. And this is the part that would be shaded in, right? That's how it would be for A to B, like with a parentheses and then with a bracket. Now if it's from A to B again, but A has a bracket, we would do points, like closed dot, A, and then open circle, B. So it would be something like this, and you would shade in the middle, right? That's for A is less than or equal to X is less than B. Right? Let me see for a second, hold on. And I know that, well, I know that obviously, you know, it doesn't look the best. That's how it would be for this one. Now, if we had something like, we kind of just move it a little bit. A is less than X is less than B. That would be an that would be from A, parentheses A, to B, parentheses, and then you would do like from an open dot with A, right? It would be like this, and then you would do to B, open dot, and then this would go on to negative infinity. This would go on to infinity, right? I know my handwriting is like really bad. I'm trying to reach the board. So that's how it would look for that, right? And then I'm trying to think. I think those are the four kind. I think that's it. Those are the four kind. Yes, those are the four kind. And you would shade in the middle, right? You would shade between A and B. You would do like a little shade here, right? So basically this entire part is shaded, right? So those are the four kind of intervals that we learn in college algebra. And they're very important because you see, when you learn like the behavior of functions and like the increasing and decreasing intervals, you use these a lot for that. So that's why you have to learn how they are. You have to learn the basics of how they are because, you know, obviously, they're very important. So we're going to go over a few examples. And let's say we have something like -2 is less than or equal to x is less than 1. We want to write that in interval notation. It's going to be bracket -2 to 1, parentheses. Remember that when it's less than or equal to, that's a bracket, and that's equal to a closed dot, right? When it's greater than or equal to, that's bracket, like going that way, and then that's equal to a closed dot, right? When it's less than, that's parentheses, and that's equal to an open dot. When it's greater than, that's parentheses on the other side, and that's an open dot, right? So you want to really remember those parts. So this one, if we were to, it would be bracket and then parentheses. One of the things that my teacher taught me was that if you do like this, so for example, if you put your fist like this, right? This is a closed circle, right? A closed dot. So if you look at the size or the shape of your hand, it looks like a bracket. That's how you would know that, oh, it's less than or equal to, so it's a closed dot, right? If it's open like this, notice that it looks like a parentheses. So it's like, oh, it's an open dot, it's a parentheses, right? So that's that's the way that they taught us. Now there is something, so basically if we have, and we're going to go over very few examples. I'm not going to go so in depth with this, but I do want to go over a few examples just to help you guys understand the difference. If we have -4 is less than or equal to x is less than 1, right? In interval notation, that would just be from -4 to 1, parentheses, bracket parentheses. If we have -4 is less than x is less than or equal to 1, this would be -4 parentheses to 1 bracket. And then you would do for this one, you would do your line, right? Then you would do from -4, right? -4, and then an open circle at 1, and then you would shade in between, right? That's how it would be. I hope y'all can see that. That's how it would look. -4 to 1, right? Let's see, for this one, it would look like this. So you would do your line, right? -infinity, positive infinity. You would do from -4 to 1, so it'd be open circle at -4, and then at 1 it would be a closed dot, right? Shade in between, and you're done. Okay. So that's how it would be. Now, sometimes they're going to ask you to solve inequalities, like, they're going to ask you, like, okay, in when you learn, like, lines in algebra, they ask you, okay, if we have, so 2x plus 1 is less than or equal to 4, or let's do 5 actually. solve for x, and you want to keep it as an inequality, right? Unless they ask you like what is the solution set, you know, that'd be different. But to do this, you just subtract 1 on both sides. 2x is less than or equal to 4. You divide by 2 on both sides. X is less than or equal to 2. And then if they ask you to graph it, you would just do at 2, right? And then you would do a closed dot like this, and then you would shade to the left, right? Less than or equal to 2. That means that all real numbers are less than or equal to 2. Now, if they ask you to do it in interval notation, right? It would be from negative infinity to 2, right? Notice that infinity and negative infinity always have parentheses no matter what, okay? They always have parentheses. Negative infinity and infinity always have parentheses. If I said, now let's say that, for example, instead of 2x plus 1, let's say we had negative 2x plus 1 is less than or equal to 5. Okay? This one's different. You have to be careful. You subtract 1 on both sides, right? Negative 2x is less than or equal to 4. Divide by negative 2 on both sides. X, and you're going to flip it, is greater than or equal to negative 2. So then you're going to say this is at negative 2 is going to be greater than or equal to negative 2. So it's going to, you're going to do a closed dot, and you're going to go ahead and shade this part, this whole part here. Okay. Now, there are some inequalities that are pretty hard. So we're gonna go ahead and just we're gonna dive through. We're gonna dive in. I hope y'all can see that. Oh, that parentheses is terrible. Hold on. Let me try to write it actually, or write it lower. Solve for x, right? We're gonna go ahead and so number 1, it's negative 2x plus 1 plus, and then we're gonna distribute our 6, right? 6x minus 12 is greater than or equal to 4. We're gonna do distributive property for x minus 4 plus 5, right? And then from there, you just combine like terms. This is negative 2x plus 6x is 4x. 1 minus 12 is negative 11. That's greater than or equal to 4x plus 1, right? And like I said, guys, I mean, this one's not going to have a solution. I can already tell. Because you'd subtract 4x on both sides. Negative 11 is greater than or equal to 1, which is a false statement. So the answer is no solution, right? If we say so we're going to go ahead and do the same thing. We have negative 3x plus 4. And let me actually change this. Okay. We're going to go ahead and combine like terms on the left. We have x plus 4 minus 4, that's just x, is greater than or equal to 2x minus 1. We're going to go ahead and subtract 2x on both sides, giving us negative x is greater than or equal to negative 1. Now we're going to divide by negative 1 on both sides. We get x is less than or equal to 1. So our solution set in interval notation would be negative infinity to positive 1 with a bracket, because, you know, obviously that is, you know, that's just how you would do it. I'm trying to think of what else. Let's see here. I'm trying to think of what else to do. Now, let's do absolute value equation, or absolute value, actually. We're going to do absolute value functions. Right? We're going to go ahead and do, so the form of an absolute value function is a times the quantity x minus h times the absolute value of x minus h plus k, where h and k is your vertex, right? That means that if we have an absolute value function, for example, the absolute value of x, this point here is your vertex, hk, right? That looks like an N. hk, where your vertex is hk, right? That's how it would be. Now, let's say we have something very different. Now, your A is actually your slope, right? Slope is just rise over run. So if we have, for example, let's say, for example, and we're gonna go over a few of these. Oh, and by the way, I forgot to do compound inequalities. Oh my goodness. Let me do compound inequalities really quick, guys. I forgot to do compound inequalities. Let me just... So compound inequalities, at least this is what I think they are. Right? When we have something like, for example, -4 is less than or equal to, or less than 2x minus 8. It's less than or equal to 16, and we want to write this in interval notation, right? Well, first we have to solve for x, right? We're going to say -4 is less than 2x minus 8 is less than or equal to 16. We're going to add 8 on all the sides, on all these parts, okay? We're going to add 8. This is 4 is less than 2x is less than, how much is that, 24? So then we're going to go ahead and divide it by 2. We get 2 is less than x is less than or equal to, I forgot to put equal, less than or equal to 12, right? So let me rewrite the 12 to 2. It's kind of messy. 12, right? So then in interval notation, it would just be parentheses 2, comma, 12, bracket. Okay. That's the main idea. When you have some of these, you want to go ahead and solve for x and then write it in interval notation like this. It's what, you know, it's not really that hard. You just have to remember your rules for interval notation. And like I said, this is very brief, so it's not going to be like firm. We're not going to do like a million problems. I'm quickly explaining this as quickly as I can because I know that well, yeah, nobody would want a really, really long video either. I'm thinking. if we actually graph a, what is it? Let's graph a, let's look at what is it called? At absolute value functions, right? If we, for example, say f of x, right? F of x, and let me equals the absolute value of x minus 1 plus 2. You want to graph it, right? So we're gonna do, and remember that the a, when we say this is your slope, and these two are your vertex. It's a point, right? So the vertex, obviously, which is our middle point, we do x minus 1, it's gonna be h is 1, right? K equals 2, right? So we're gonna do 1 comma 2, and we're just gonna go up, right? 1 1 1 1 1 1, and then we're gonna do the opposite, right? Because remember that the shape of an absolute value function is basically like this, right? It's like a V. So we're gonna do the opposite. It's gonna go up 1, left 1, or you can just do the reflection, right? Since this is your vertex and you're going like this, you can draw like a little line here, like a dashed line, and you can just reflect. So then it's like this. It's like 1 2 3 1 2 3, right? And then you would go ahead and just do that, right? And that would be your graph, right? Now remember, if I have something like this, it would look something and you would go down, right? Because the outside is a negative, right? Be 1 1, right? So 1 1, and then you would keep going. So it's kind of, so like I said, your slope or your point, your vertex is 1 2, right? So then you would do down 1, right 1, and then down 1, right 1, down 1, right 1, and then you would draw like a little dashed line to tell you like, oh, you know, you would do the opposite because it's supposed to be an upside down V, right? It's gonna be down 1, left 1, down 1, left 1, down 1, left 1, down 1, left 1, right? So then it's gonna look something like this. It's not the best sketch, but that's how it would look. That's how you know it's upside down, right? It's pointing down. So basically, if a is less than 0, you're going to have something like this. If a is greater than 0, you're going to have something like this. Okay. Let me write that a little bit better. Right? So that's how that works. Now for absolute value equations, it would be, so it would go, hold on. So if we have something like the absolute value of x plus 1 equals 3, so that you're going to have two answers, x plus 1 equals 3, or x plus 1 equals negative 3, right? You solve for each one you solve each one for x, right? So it's going to be x equals 2, or x equals negative 4. And you can plug it back in. The absolute value of negative 4 plus 1, is that equal to 3? Well, negative 4 plus 1, that's the absolute value of negative 3. The absolute value of negative 3 is equal to 3, so that's going to be 3 is equal to 3, right? If you do 2, so the absolute value of 2 plus 1, is that equal to 3? Right? You're going to say the absolute value of 3 is equal to 3, so 3 is equal to 3, right? That's how you verify. So then we get to inequalities, right? This is where it gets a little tricky. Inequalities, you don't graph them. I mean, you do, but you do them on a number line. So for example, if I say something like, right? Or let me do 3 actually. You're gonna do the same as an absolute value equation. You're gonna add 1, right? And let's make this negative, okay? So that we can get the negative 1 out of the way. So then we have negative 2 times the absolute value of x plus 1 is greater than 4, right? So then we're going to go ahead and divide by negative 2 on both sides. And then notice that, and this is greater than or equal to, by the way. And then notice that since it's divided by a negative, you want to go ahead and switch the signs. So it's going to be the absolute value of x plus 1 is less than or equal to negative 2, right? That means that x plus 1 is less than or equal to negative 2, or x plus 1 is greater than or equal to positive 2. Okay? It's crazy, I know. It's weird. But you then subtract 1 on both sides for this one. You do x is less than or equal to negative 3. And then you do the same thing for this one. You subtract 1 on both sides. You get x is greater than or equal to 1. So then if they ask you to graph it, you do x is less than or equal to negative 3, right? So it's going to be negative 3. You're going to do a closed dot, and then you're going to shade on the left. And then you're going to do x is greater than or equal to 1. Right here. That's a 1, by the way. You're going to do a closed dot, and then you're going to do greater than or equal to 1. Shade on the right. Okay. That's how that works. So, yeah, that's how absolute value inequalities work. If you want to look more in depth, there's a whole video on it on my YouTube channel. But yeah, that's just how they work. I'm going very briefly. So then we get into systems of equations. Yay. Right? There's systems of 2 and systems of 3, right? Hold on, guys. I'm looking. So let's look at x plus y equals 3 and 2x plus 2y equals 6. Let me see, hold on. Actually, never mind. Those are the same equation. Never mind. Hold on. Hold on. Let's look at 3x plus 2y equals 19 and x plus y equals 8, right? We're going to go ahead and solve for y for this by, we're going to solve for this by substitution. So we have x plus y equals 8. We're going to solve for x, or solve for y, excuse me. Let me do y equals 8 minus x, right? So then we have 3x plus 2 times 8 minus x. We're going to plug that into this equation, right? For y. Then we have 9, that's equal to 19. So then we have 3x plus 16 minus 2x equals 19, right? We have x plus 16 equals 19. Then we're going to subtract 16 on both sides. Okay. And we get x equals 3. Now, we're going to plug that back in for our y value. So basically we have y equals 8 minus x, okay? We have x equals 3, so then we have y equals 8 minus 3. So then we get y equals 5. So the solution as an ordered pair is 8, or not 8, sorry. It would be it would be 3 comma 5, right? So that would be our solution for this one, right? That's as an ordered pair, that's what the solution is. Sometimes they're going to give you x equals 3 comma y, or x equals 3, y equals something, or sometimes they can give it to you as an ordered pair. Now by elimination, let's say we want to go ahead and solve that one. That same exact one by elimination, right? And then x plus y equals 8. Right? So we're going to solve it by elimination. The way that elimination works is you want to go ahead and cancel out one of your variables. So to do that, we have a 3x. What do we need to cancel in the x out? We need a negative 3x, right? So you're going to multiply this entire part by negative 3. So then you have 3x plus 2y equals 19. And then you're going to do minus 3x minus 3y equals negative 24, right? So then you have 2y minus 3y, that's negative y. And then, okay, sorry guys. And then you have, so negative y is 19 minus 24. If you subtract that out, we get a 5, right? So it's negative 5, right? Then we divide by negative 1. So then y equals 5, right? And now we go ahead and plug it into x plus y equals 8. So then we have x plus 5 equals 8, right? X plus 5 equals 8. We subtract 5 on both sides. We get x equals 3, right? So our solution is 3 comma 5. So now we're going to do systems of 3. Systems of 3 are very interesting. Let me, hold on. Hold on, guys. Let me do systems of 3. So Hold on, guys. I'm looking. Because I know these. I'm looking for more examples. Let me just. Okay, so we're gonna dive in. 4x minus 2y plus 3z equals 1. Right? X plus 3y minus 4z equals negative 7. So x plus 3y minus 4z equals negative 7. Right? 3x plus y plus 2z equals 5. Now we're going to solve this by substitution. Let's solve the second equation for x, right? So x plus 3y minus 4z equals negative 7. So we're going to go ahead and subtract 3y and add 4z on both sides. So x equals negative 7 minus 3y plus 4z. We're going to go ahead and what is it called? We're going to go ahead and plug that in for our two other equations. So 4 times negative 7 minus 3y plus 4z minus 2y plus 3z equals 1, right? We then distribute, right? We have negative 28 minus 12y plus 16z minus 2y plus 3z equals 1, right? So then we have negative 28. So then we have negative 28 minus 14y plus 19z equals 1, right? Add 28 on both sides. You get negative 14y plus 19z equals 29, right? Oh my goodness, I don't know why. And if y'all hear background or noise in the background, it's Easter today, so my family's here. Let me... So we have that, right? And then we're gonna go ahead and so let this be, so hold on, let this be new equation 2. So we're going to change new equation 2 as that equation. So we have negative 14y plus 19z equals 29, right? So then we're going to go ahead and do the exact same thing we did for equation, but except this time it's going to be for, oh, sorry, hold on. It's not new equation 2, it's new equation 1. Excuse me. So this one turns into negative 14y plus 19z equals 29. Right? This one, the second one, was the one that we came up with, which was x equals negative 7 minus 3y plus 4z, right? And then for the third one, we're going to go ahead and do, we're going to plug x in. So we have 3 times negative 7 minus 3y plus 4z plus y plus 2z equals 5, right? Distributive property, you do negative 21 minus 9y plus 12z plus y plus 2z equals 5. So then we have, let's add 21 on both sides right away to get rid of that part. Negative 9y and y, that's negative 8y. 12z and 2z, that's 14z. 5 and 21, that's 26, okay? So that's what this one changes to. So now we have a new systems of equations, right? With three, like, it's like 3 equations. So basically, we have the following. We have negative 14y plus 19z equals 29. X equals negative 7 minus 3y plus 4z. And then, what else? Negative 8y plus 14z equals 26. Now, since this is by substitution, well, we can solve for, so basically the one that says x equals, we don't have to worry about that one anymore because it's just x equals. We don't really have a need to use it anymore. You know, that's the one that we substitute. That's the one that we solve for at the beginning. So the main thing is you want to make it so that it's the systems of 2, so that way you can solve for it better, right? You can solve for a variable. Your goal is to solve for a variable, so that way it becomes all very clear. You do negative 14y plus 19z equals 29. Let's solve for y or z. So then we have 19z equals 14y plus 29. Right? Z equals 14y plus 29 all over 19. So then plug this into the other equation that says negative 8y plus 14z, right? So you're going to do negative 8y plus 14 times the quantity 14y plus 29 over 19 equals 26. Now you can go ahead and do like multiply everything by 19 to get rid of the fraction, right? So you have, let's see here. Negative 152 y plus 14 times 14y. I hope y'all can see that. Oh, I'm trying really hard to write it as best as I can. times 14y plus 29 equals 26, okay? Now, let's rewrite that. Let's rewrite that over here. I'm gonna go ahead and just move. So, negative 152, right, plus 14 times 14y plus 29 equals 26, right? We're going to do distributive property, then we have negative 152 plus, and then that's going to be, I think, how much is that? That's 196, I think. 14 times 14, 196. And then 14 times 29 is 406. So now we have negative 152 plus 406. So 406 minus 152 is 254. So 196y plus 252, or 254, excuse me, equals 26. Now go ahead and divide both, or subtract 254 on both sides. 26 minus 254 is negative 228. I really hope this is right, because honestly, sometimes I do struggle with these guys. I do apologize. Let's see here. Oh, and by the way, oh my goodness, over here, when I multiplied by 19 to get rid of it, I forgot to do the same thing on the right. This is supposed to be times 19. Oh my goodness, this is what I'm talking about. Oh, 26 times 19, that's 484, so it's going to be 196y plus 254 equals 494, right? You're going to go ahead and subtract 254 on both sides. You get 240, right? Guys, I think I'm gonna continue later because right now I feel like everything is very noisy. I'll continue later with this stream, and then I'll rework this out, and then I will see you guys later, because right now, honestly, it's a lot of noise over there in the living room, and family is here, so I will see you guys later, because yeah, I don't think right now is a good time to be doing this. So I will see you guys later. If this did help, please let me know. I'm gonna do this again, because obviously this problem is just really weird, but other than that, I hope that what